So, hello everybody. I hope you can hear me well. Good afternoon, everybody. Welcome to this last session of the day. Thank you for sticking around with us. I am Susan Sayed. I'm a scientific researcher at the German Meteorological Service in Offenbach, and I'm working currently on the climate change adaptation digital twin for the user engagement and user support. And I will moderate the session here today. And we are here to inform you about the project, which is a part of the Destination Earth initiative that you maybe have heard of. But we would also like to get some information from your side as users, potential users. So we would like to clarify questions like what are your needs, your expectations on such a climate service like Climate DT? Um, and to keep things interactive, we will be asking some questions throughout the whole session via Mentimeter. If you could go to the next slide, please. Yeah, you can find a QR code on the slide. Please take your phone and just scan it or go to the website on menti.com and enter this code that you can see here. I will wait a couple of seconds. Yeah, the code is also now in the chat. Um, And yeah, please leave this tab open throughout the whole session because we will come back to it every now and then and we'll use it to ask you some questions and get feedback from your side. And I hope this works for all of you. And we can wait a couple of seconds so everybody has a chance to reach this website. And in the meanwhile, please always feel free to use the Q&A box and or raise your hand so the organizers are able to unmute you and you can ask your questions directly to the speakers. So I hope you were able to find this and we can go to the next slides to begin actually with the first question because we would like to get to know you, the audience, a little bit better and please respond to us. How would you best describe your professional role? We would like to know who are you? Please just type in what you think. Yeah, we have this climate scientists, adaptation, research, doctoral students. Very interesting. Okay, it's very variable and it's very interesting. Most of them obviously in climate science sector, and we're still getting input. Great. And always keep in mind this is anonymous, so um, this will not be saved. Your information will not be saved. Um, Great. Communicator management, PhD students, NGO engagement, many scientists and researchers. Very interesting. Okay, we have another one actually prepared. If we can go to the next question. What is your scientific domain? What's your sector or area of expertise? Is it in the hydrology? Is it wherever? Please respond to us. Okay, risk, climate modeling, urban, wind industry, climate services, obviously many urban people, wildfires, water management. Okay, thank you. And I think we can go on. with the last introductory question, which is actually how familiar you are with this project we are going to present. Please rate how familiar you are with the Climate DT project or with the Climate DT data. You have several options. I've never heard about it before, or you're familiar with the vision and objectives. You're familiar with like to start using the data, or are you even using the data, or others? Okay, so I see a clear trend that most of the people either have never heard about this project before or are familiar. And we have some people that already have used the data. That's very nice to hear, actually. Okay, we have about 30 responses. I would say now's the last chance before we move on to our first talk, actually. We can go to the next slide, please. Yeah, the first talk will be a general overview of the Climate DT, will be given by Jenny Kontganen. Jenny acts as a service manager in Destination Earth Climate DT project and coordinates also a connected Terra DT project. And she leads a group on digital twins at the CSC. It's the IT Center for Science in Finland. And now, Jenny, the floor is yours. Please tell us more about the project.
Okay, great. Thank you, Susan. And hello, everyone. It was very nice to see also in this introduction part that who are there listening to the talk. Okay, so I will give very brief overview of the climate digital twin. I don't have too many minutes, so this will be very short, but then you will, after my talk, hear more about the details of different aspects of the Climate DT project, like Susan already mentioned. So I will start with the very basics. So first of all, the Climate Digital Twin is part of the Destination Earth initiative. And this is a very ambitious European Commission's initiative that aims to develop digital twins of the Earth to support decision-making on topics such as climate change. And Climate DT then combines high-resolution global climate models in a new way with impact sector applications. And the overall goal is that it produces information that can support climate adaptation actions. And the key novelties of Climate DT are that it provides multi-decadal climate projections at very high resolution, so at 5 to 10 kilometer spatial resolution, with 3 coupled climate models. The models are IFS NEMO, IFS FESOM, and ICON. Climate DT also provides first ever operational capability for climate projections, and its aim is also to provide capabilities for addressing so-called what-if questions by the users. And an important novelty of Climate DT is that it provides actionable information for different sectors, and this is done by bringing climate models and impact sector models within the same workflow. And if you go to the next slide, the illustration there shows a bit more what this can mean. So here on the left-hand side, you can see the climate adaptation digital twin. And then on the right-hand side, you can see what kind of information this digital twin produces. So if you look at the digital twin box first, we can see, first of all, there are the coupled kilometer scale global climate models that I was just mentioning about. And they produce data that is they produce data both regularly as well as on demand to address specific questions. And this data is then streamed to different applications. These applications include an application for quality assessment and uncertainty quantification. There is also an application that calculates on-the-fly statistics and also bias adjustments. And finally, there are different applications for impact sector, and we will hear more about those after my talk. So they evaluate or provide information on the impacts of climate change on different topics based on these kilometer scale global climate data. And then on the right-hand side box, you can see the information that the climate DT produces with all these different components. So this includes these multi-decadal climate projections, as well as so-called storylines of future extreme events. So these are produced by these kilometer scale climate models. We will hear more about these storylines later in this session. And then, very importantly, the climate DT produces these user-relevant indicators via these different impact sector applications. You can go to the next slide. So this slide then illustrates the availability of the climate DT simulations. So the first simulations are already available at Destination Earth platform. You can find it from this link there. And new simulations will be added there, and completely new kind of set of simulations is expected to be there this summer. So you can see, if you look at this figure that illustrates the simulations, that there are different types of simulations. So there are control and historical simulations, as well as future projections. And also then with the IFS-VESA model, there is this special, also there are those special storyline simulations that we will learn more about later in this session. Accessing all these climate DT simulations requires that you will access this Destiny platform, and then you apply for upgraded access. And this upgraded access will be granted to individuals who are from European public organizations. So let's say, for example, universities or other organizations, or then also from SMES. More information about climate DT, also with some examples how you can access data, you can find from that page that I have linked there. You can change to the next slide. So finally, I want to mention that the climate DT is implemented by an international partnership that is led by us at CSC IT Center for Science. And this partnership involves 12 European organizations, and this is implemented through a contract that is procured by ECNWF. And you can see all the organizations contributing here on this slide. So this was my extremely short overview to the climate DT, but we will soon hear also more about these different impact sector applications, and then also about the storyline simulations.
Thank you, Jenny. Thank you very much for this interesting talk. If we go to the next slide. Yeah, we already have one response, actually. There's another question. What do you need climate data for in your work, and what do you think is the added value of the climate DT? So this is an open-ended question. You can just type in your answer. I think it's limited to 200 characters. And this gives us a really nice insight from your work, and what you think the climate DT can help with your work. So we have two responses. Researcher, provide more accurate climate service to understand how extreme events will change in the future. Very interesting. Need climate data to predict risks and optimize responses. The data is needed for creating CS, for a more realistic assessment of current and future climate hazards and associated risks, more credible and equitable information. We should keep this open for a little while, and in the meanwhile, Jenny, I would like to follow up, just a little follow-up questions. So you talked about operationalization, and could you say some words about the timeline maybe? So where are we now? What have we achieved so far? When this project actually started? And what are the next steps?
Yes, very good point. So currently, it is the second phase of this project. So in the first phase that started in 22, we developed the very first prototype of this overall climate DT. So this meant basically just putting together for the first time these all these different kilometer scale climate models, these applications, developing the workflow, all these kind of things. And now then, so the first phase lasted a bit less than 2 years, and now the second phase is ongoing. And now in the second phase, we will then, or we are focusing on moving this system towards an operational system. So this means that we don't yet or let's say so that we are still developing the system, but in the meanwhile, we also develop this kind of operational framework that shows that how climate DT could in the future then be used to regularly produce climate information. So basically the idea in the operational framework is that the climate DT could provide new data more regularly than the current climate modeling activities. So this could be, for example, once or twice a year, and this would then greatly kind of increase the frequency that the users get access to new updated climate data. So this is where we are now. And yeah, so the second phase will continue still until next year's April. And we are now just at the point where we start these kind of first we call them operational simulations. So those are also those kind of next simulation set that I mentioned that will be available hopefully in the Destiny platform then in summer.
Okay, thank you very much. Could we scroll down a little bit so maybe we can have a look at some further answers if it's possible, and always feel free to raise your hand and say something about what you have written here. It's very interesting. Support adaptation, for example, by local authorities. Climate DT hopefully standardizes industry impact data. Okay, very interesting. Evaluate climate impacts on energy demand and more. I think it's not possible to scroll down, but that's okay. I have another question to you, Jenny. So you talked about the workflow. So you have shown this figure where the climate information is produced and then given to the chain. So what's actually the advantage? So why do we need this new concept? We have other climate services, but what's like the advantage of the climate DT with respect to existing services?
That's also a very good question. So one of the advantages is that then these users who can now be, or let's say people who are working in these impact sectors, who have these impact models, they really, when we are streaming the climate data to these impact models, this means that they get access to this data as soon as it is produced. So then this, like I already mentioned, this kind of increases the frequency when the new data set is available, when you don't have to wait for several years that you get access to new data set. There is also the additional benefit that because this climate or kilometer scale climate simulation data, that is of course like or the models produces huge amounts of data. So also this kind of streaming approach allows it that we don't have to necessarily even store all the data in long term. So this is currently still a bit in the process. That is what does this mean in practice? That which data we wouldn't necessarily store in long term, but in principle, this streaming solution enables it that as the applications can ingest the data, like the full resolution data real time, then it means that we don't necessarily have to save all the data in long term. So at least those two benefits come to my mind. And of course, Susan, you can add also if something else comes to your mind.
Yeah, just to add maybe, so the data is of course not gone if you're too late or not able to use the streamed data. data will be pushed to the data lake, not in the high resolution, but it's still available also to reproduce any outputs that you have. And so don't
That's
worry,
very
it's
good
not gone.
clarification. Yes, I didn't mention that, but important part of this is definitely that we utilize the destination Earth infrastructure, and this includes this destination Earth data lake where the data is stored. Yes.
Okay, thank you very much. And we can go to the next slide. Thank you. Now we will come to a very interesting part of the session where we talk about the climate DT use cases. So use cases, what is a use case? So each use case aims to demonstrate the capabilities of the Destiny infrastructure um, to provide actionable information and decision support to its actual end users. And we are following a user-centric approach. And this applies a very early engagement with some selected key users and a continuous improvement of the system using user inputs. And yeah, as you can see, we have 4 use cases here, and we'll start with the first one. It will be the wildfire use case. Um, this will be given by Suraj Polade. He is a climate scientist at the Weather and Climate Change Impact Research Unit at the Finnish Meteorological Institute. And his work focuses on understanding regional hydroclimate changes that are driven by anthropogenic global warming and their implications for decision making and natural resource management and other regional societal application. So, Suraj, the floor is yours.
Thanks, Susan, for nice introduction. May I have the next slide? Yeah, perfect. So the wildfire application in climate DT was developed with a general idea of managing wildfire and adoption. As we already know, wildfire was the threat to the society and ecosystem directly through the fire itself, as well as the causing the bad air quality and affecting the large number of people and resulting in the significant economic damage. The earlier studies has found the climate change is increasing the frequency and intensity of fire weather, which favor wildfire outbreaks. Therefore, there is urgent needs to enhance the resilience in landscape and communities against the extreme fire weather events in Europe as well as globally. This application, what we are developing in climate DT, can support the risk identification and the evolution of management strategies for the wildfire. To identify the user needs and requirement that climate DT can address, we focus on the users such as researcher, practitioner, decision makers, which are involved in the risk identification and testing managing solution. These user needs are co-developed through the direct interaction uh, with the user. And through user interaction, we have identified key needs and requirement, what's stated here, such as how will the fire spread change in the future under different climate scenario, or how can we limit the fire spread and danger, or how will the fire regime change. This was specifically for the boreal forest, but it can be extended to the different region as well. So to address these needs, we have the 2 application, the Canadian Weather Fire Index, FWI, which is for the assessing the fire weather condition, and the Wildfire Intelligence and Simulation Engine, the WISE, which is the deterministic fire spread model. Susan, can I have the next slide? Thank you. So FW application provide the fire regime over the broader region. What we can see here, the left-hand side figure is the extreme climatology value of the FWI over Europe. And the Canadian Fire Weather Index, it's actually meteorological based index used globally to estimate the fire danger. It directly doesn't provide you the actual fire occurrence or the burn area, but instead provide the indications of the weather condition that contribute to the fire risk. So by setting the FWA value for the specific region, just what we did it here for the Finland's one region, WISE can help you support the local and regional assessment of fire risk and the adoption measure. It provides insight into the fire dynamics, such as the fire spread, intensity, burn area, which is influenced by the prevailing fire weather condition. What we can see here in the illustration of the right hand side of the figure. This application will also offer the potential what's if scenario to the end user to explore the wildfire extent intensity under the different land use practice, fuel management strategies, or creating and the maintaining the fire breaks. And this eventually will help the end user to develop their own adoption strategies. I think that's it. Thanks, Susan.
Thank you, Suraj. And we can go on with the next. Thank you. With the next use case, which is the hydroland use case. This is going to be implemented by Aparna Chandrasekar and some others from UFZ. Aparna is a chemical engineer at the Helmholtz Center for Environmental Research in Leipzig, Germany, and a researcher specialized in hydrology and climate impact analysis. And she's dedicated to advancing sustainable solutions for water resources and environmental resilience. And now I give the word to you, Aparna, please.
Thanks very much for the introduction, Susan. So the Hydroland application is again an impact application, as you saw in Yenny's presentation. So we basically utilize the climate data in order to provide information on the terrestrial water cycle. So basically the water cycle on land. The main motivation behind developing this application is because climate change can really impact, or it's proven that climate change impacts the terrestrial water cycle. And we see an increasing incidence of both droughts as well as floods in many regions across the world. And what we want to do is basically provide an operational tool where you can understand the impacts of climate change on floods, droughts, as well as many other variables in land hydrology. So some of the needs that we were given by our users is understanding the change of certain variables like runoff and soil moisture in certain regions. So for this, we are able to provide, for example, regional data, so data on certain catchments in Germany or in other regions of the world, and just provide what these variables look like in the past as well as in the future. Another need was, for example, preserving the water quality of smaller lakes and reservoirs. So especially during droughts, the water quality of small lakes could be drastically affected. So while we don't provide directly water quality indicators, understanding the incidences of droughts and floods in these regions could help the stakeholders understand how this affects the water quality. Another information that was required was how crop productivity would change, or how would food security look like in the future. And for this, we can provide aridity or soil moisture deficit indicators that can then be used by our users to calculate the changes in crop productivity, economic losses, or that actually result from this. Next slide, please. So I guess the next one is basically a question for you. So which kind of events do you think is really interesting for your sector? So is it like a flood event or a drought event or both? I think the main motivation behind this is that I think they basically impact different kind of sectors. So if we look at droughts, it's more the agricultural sector that's been affected by it. And when it comes to floods, it's more of sectors like hydropower, or yeah, such sectors could be affected. So I'm just trying to understand what kind of stakeholders are there, what kind of events would be interesting for you all. So it looks like mostly both of such events are interesting. So far, the 18. Okay. I'll just wait for maybe 10 or 15 seconds if there are more people who want to respond. Okay, so it looks like it's mostly so the people at least over here seem to be interested in both of these events. Okay. So what is the solution that we provide? We basically have an impact sector model, which is a global gridded model containing various land hydrology processes. This is called as the MHM model, which is developed within the UFZ. This is able to take this global climate model data directly. We use especially temperature and precipitation to drive the model, and we are able to provide variables like discharge, runoff, evapotranspiration, soil moisture, and then convert them into relevant indicators, which actually impact these sectors. So for example, like you saw, what is the frequency of, for example, sub-daily floods? Or droughts with an intensity which could be also defined by the particular sector. Another novel feature in this hydroland application is developing what-if scenarios. So how we do this is basically we can change parameters within this model, which is the MHM model. So for example, change the land use masks, change some soil parameters, and just see the impact of certain policy decisions. For example, converting to organic farming, you can understand the impact of this also on, for example, aridity or the soil moisture deficit indicators. Yeah. Next slide, please. Yeah, I think
Thank you, Aparna.
Thank you.
And I would just raise this one question because this was raised to you. We have one question in the chat, and I will just read it out, and then you can just answer to it. So, does hydroland include non-climatic data needed for flood risk assessment, such as about reservoirs and dams, dikes and retention areas, etc.?
I'm not sure I completely understand it. So what I can just say what I understand. So what I get it is if apart from non-climatic data, if certain reservoirs are represented within the hydroland application. So my answer for that would be basically this model operates at the same resolution as that of the climate models. So far we are able to go until 5 kilometers. This means if there are any reservoirs which have this, which are visible within this 5 kilometers area, then yes, we are able to show the impact of climate change or give information on this. Yeah, I hope it answers.
Yeah, thank you very much. I hope it answered too. It was an anonymous, so I hope please raise a question or a hand if you have a follow-up question. But yeah, thank you very much, Aparna, and
Thank you.
thank you. We can now go on with the third use case, the hydromet use case. This is going to be implemented by Karl Hartig, a colleague of mine from DWD. Karl investigates various kinds of hydrometeorological extremes with the help of high-resolution model data. And currently he works as a scientist at DWD to look into extreme precipitation in the future. And Karl, you can start.
Thanks for the introduction. So we have the hydromet application here, and in difference to hydroland, which looks at the effect of the precipitation, we look directly at the extreme precipitation itself, which, as you can see here, can cause floods and other disasters. Yeah, and it's probably common knowledge that the impact of climate change is often felt through such extreme events that everybody hears about and maybe even feels them themselves. And for the future, it will be important to identify changing characteristics of such events and estimate the likelihood that they occur. An important term in this context is the return time. So, for example, how strong is a rain event with a 5-year return period now and in the future? This is one of the needs we want to answer. And another other characteristics of extreme precipitation, like how much area is affected by a typical thunderstorm, are the common duration times of such events changing? Do we get more short outbursts or longer events? This is what we want to answer. And to activate your thought process on this a bit, I have a question for you in the next slide. So on the Metimeter here, an extreme precipitation event with a 100-year return period happens only once every 100 years. So I give you a few seconds for that. But the tendency, we see some true dots there. $14 people. Thumbs up. Yeah, I guess that's enough time. So the majority is right here. Of course, also the way I phrased this question. So false is correct. So if we have an event with a 100-year return period, there's a percentage of 1% every year that this event happens. Yeah, but actually the assumption is also that this 100-year return event stays the same. So there are no disturbances in the climate, and 100-year event is always the same. But we probably see with climate change that this is not the case, and Hydromet wants to answer that. Can show the next slide. So what we do is we take like Hydroland, we take the high resolution precipitation data of destination Earth climate T, use our algorithms to get a probability distribution and arrive then at curves we see here. They might look quite complicated, but I'll show you quickly how you can handle that. So if we Hydromet calculated these curves, you can pick a duration, for example, here 72 hours, and then you want to look at the 100-year event. Then you arrive here at the most above line here, and you see that such an event has an expected rainfall depth of 70 millimeters. This is for a specific area and duration you calculated, and now with the climate change, these curves are expected to change, mostly upwards. So under a new climate, we then expect that a 100-year event will have a much stronger rainfall depth, and the 70 millimeters we found for the historical periods will be a typical event with a much shorter return period. So these are depth, duration, frequency curves. That's why I called, and they are important for adaptation strategies and environmental planning. Another thing we output is an extreme event catalog. So we catalog all the events that happen in the simulation, and then this can be plotted on a map. But as said before, much more important, we look at the distribution, are we detect more small scale events in blue here, so very limited events or much larger events, and how does this evolve with climate change in the projections? Do we get more small scale events or less? And the same for the duration shown here. So are there more shorter events, or do the duration times generally increase? Yeah, that's it. Thank you.
So thank you, Carl. And we can move on to the last use case, which is the energy use case. This talk will be given by Francesc Rura Acerias from the BSc. Francesc is a workflow engineer at the Barcelona Supercomputing Center, and he's in charge of the data streaming and the implementation of the energy use case in this project. Francesc? You're still muted.
And now?
We can hear you now. Thank you.
Perfect. Yeah, let me jump to another topic, and let me start setting the ground for why are we doing that? So I will just read the question aloud. So in the context of a changing climate, should we consider it when planning the future installation and operation of wind farms? This may be an obvious question. I give you 10 seconds to answer. Yeah. Okay, please don't select the option because you see that everyone is selecting the same. Okay, good. Yeah, 13-1. So this is a question that may be obvious for you, but when I brought this question to our key user, the answer was, no one is using climate data for the future to answer this question. So how can we answer our key user and the wind industry to tackle this, to tackle the changing climate in the sector? So next slide, please. We are providing local information at a global scale. And for that, we are providing indicators that are relevant for assessing the wind energy resource. Let's say which locations are going to be suitable for the installation of the new wind turbines in the future. Are the locations of the current windmills, are they going to be also profitable in the future? These are questions that the sector asks, and we try to answer these questions by providing indicators that they need. Here we are showing just an example. Something that is very important for the wind industry is the distribution of wind, the wind distribution. Using the high resolution data from the climate DT, we can get here in the center, we get the distribution for a certain point, and a derived quantity that is the capacity factor that can tell us an estimation of what the production would be in this location. So we are helping in the past to see what would have been the energy yield in the future, in the past, and compare it to what actually happened, and see what is going to be in the future for the ones that already exist, or for the ones that can be installed in the near future. And something that is also important is that not only the climate is changing, but also the technicalities of the sector. This brings me to the point of the what if scenarios in our sector. So could you please go to the next slide? Some concern that was raised from our user is what is going to be the energy yield in the future if we are changing the turbine that we use. So for the turbines that we had in the past, it's relatively easy. We have numbers of what was the production and the wind resource in one place. We have the details of the turbine that is depicted in this left bottom image that is called the power curves, but we don't know how this is going to be reflected in the future. So we can get different turbines with different heights. So it's not the same, the energy production of a turbine that is 100 meters tall or 120 or 80. And this can change in the future, and we have to provide solutions to them. And this is how are we tackling the what if scenarios in our use case. And that's it. Thank you very much, and waiting for your questions in the end.
Thank you, Francesc. And we had a question. I think it was related to Carl's talk, but this is actually a question that could be to all of you, because you so the question was anonymous: is the model scalable and replicable beyond Europe? And the general answer, I think, for all use cases, yes. So the use cases, the applications can operate globally, which Carl also already answered. So if we go to the next slide, please. We have prepared a couple of other questions. So this is one that Suraj wants to ask you. Yeah, now I can see it. So this is related to the wildfire use case. Suraj, do you want to take care of this?
Yeah, thanks, thanks, Susan. So we want to know how you currently using the wildfire weather data. We have given the couple of options, although you can choose other as well. So you are using like current wildfire or wildfire forecast or fire occurrence information or fire losses or special fire risk estimate or future wildfire risk estimate or the information on the wildfire risk mitigation. Is it possible, Susan, to see the answer given in the others?
I would ask this to Chiara or someone from CMCC, but I think not. No,
Because
I
we,
just
we,
have
we
the
have
answer.
many answers in the other, and the
Yeah,
second
maybe
was
those who voted for other can just briefly write it in the Q&A. That would be really helpful, actually, for Suraj and us to have this information also, because yeah, it's quite a large amount of people. So if you have voted for other, please just write a comment in the Q&A so we have noted this. That would be really great.
Yeah, maybe we can wait a couple of seconds more before we move
Yes.
on further.
We already have one. Okay, this is someone who is actually not using wildfire weather data.
All right.
We can maybe wait for 10 more seconds and move on with the next one. There's still some fluctuation. Yeah, I think we can move on.
All right. And second question is also again related to the wildfire application. So here we want to know, are you, if we can make the ability to integrate your own data sets, such as the risk location or vegetation or the fuel type, is that interest you? And it's more yes or no questions. Maybe we wait for another couple of seconds before moving on. Okay, it looks steady now. Thanks for answering. Let's get back to Susan.
Yeah, can we move on, please, with the next slide? Yeah, so this is more to all of the use cases, or which indicator or variable would you like to see represented in the applications? So do you have any use cases or applications you're working on right now, and is there some unmet need of in any impact sector where you need an indicator, a variable? It's not addressed much right now. I can see urban heat stress. Okay. Obviously, there's a need for more indicators for this. Zero crossings, precipitation, water scarcity, groundwater levels, community surface air temperature, soil moisture, heat wave. Okay. Proximity to energy demand, near surface wind at several levels. Okay. Can maybe wait a couple of seconds more. Grid quality. Yeah, feel free to raise your hand if you have any, if you want to elaborate your points. Okay, I think it looks steady now. We have a couple of responses. And now this is also for all of the use cases or users of the potential use cases. How useful would a what if scenario tool be in your operational planning or research? You can rate this usefulness from a scale out of 1 to 5. So 1 is not useful at all, 3 is somewhere in the middle, and 5 would be extremely useful. And we can clearly see a trend. So most of the people think that this is at least useful or even very useful for their work. And that's very nice to see, actually. Can wait a couple more seconds. But I think it looks good now. We have 16, 17 answers. And I think we can now slowly move on. And those who said it would be useful for you, which what if scenario would be actually interesting in your field? So what are questions that you would like to answer in your field? You can type in, it's an open-ended question. You can type in your answer. And I see a question in the chat right now. What if scenarios would also be interesting for other things than wildfire? Yeah, this is the place where you could type in now your answer. this is dedicated to all of the impact sectors. So whatever questions you think needs to be answered, just paste your question here. I know this could take a little while because it's a little bit more text, but we already have one response. Different urban design on urban heat island and heat waves in cities. Various degrees of warming. What would a historical urban extreme event would look like under future plausible meteorological conditions? Okay, this is very interesting. Impact of the collapse of the Gulf Stream. Okay, so this is more on the model side. If you can think of what if scenarios on the application level, you can also paste it here. You can wait a couple of more minutes. Playing with return periods and intensity levels of precipitation. So that refers to what Carl just presented. Interesting. Okay. So I would leave this open. So maybe people have some answers still and go through the Q&A. I saw that Francesc has already answered some questions. Maybe you can just quickly summarize what you answered here.
Yep.
So it was about the
Do you hear me?
uncertainty. Yes, we can hear you, but we cannot see you right now.
Yeah, too many buttons. Yeah. Basically, I think the two questions were addressed towards the assessing the goodness and the uncertainty quantification of these indicators, and this is something that it's a work in progress. Something that for sure we want to provide together with indicators.
Okay, thank you very much. And in the meantime, we have other answers. Alternative types of agriculture would be a nice what if scenario. Sea level scenarios for coastal areas. How can specific land use changes or flood protection measure decrease flood risks at different warming levels? Okay, that's a little bit more complex. Okay. I think we can now move on. With the actual, I think, last question for this block. And this is also a question to you all. Which resolution are you working with at the moment and what do you require? So we would like to know what are the gaps, what are the needs in case of spatial and temporal resolution? Are you facing problems with this at the moment? Again, this is an open-ended question. Just type in your answer and we can wait. Five kilometers 1 hour, but require higher possible in both. So it would be it would be interesting on which variable and why also. You can also just paste it in the Q&A. From 25 to kilometer scale, our users want even higher urban level around, okay, that's of course 100 to 200 meters. We can wait a couple of more seconds and then move on. Two-meter resolution for thermal comfort. Time resolution is also important, where hourly is something sometimes needed. Okay, very variable answers here. A 100 meters for groundwater levels, but very local. 5 kilometers, very good globally. Time not so important. Okay, also interesting. Spatial is more important than temporal here. And I think this is the last question for this block, so this will be left open, and we can move on. So you can still type your answers here. Yes. And so for the next and last talk, we will have a talk from Catherine Grayson from BSc about the very novel thing about this project, the storyline simulations in this Climate DT project. So Kat is a postdoctoral researcher in the Climate Services Group in the Earth Science Department at the Barcelona Supercomputing Center. And her research focuses on the analysis of high-resolution climate projection in the context of destiny. And Kat, I will now give the floor to you.
Thanks, Susan. Can everyone hear me?
Yes, we can hear you and see you.
Fantastic.
Yeah.
Okay.
Okay, you're talking through Francesca. Okay.
Yeah, I'm speaking through the speaker, Francesca. Cool. Well, firstly, thank you everyone for sticking around. I think this is the last presentation of the session and of the day, so it's really appreciate you still being here. I wanted to talk very briefly about another type of simulation that we have as part of the Climate DT, which are the storyline simulations. Now, normally when we talk about climate models and how we can use them to understand climate change impacts in the future, we talk about using these climate models to run projections. Now, with a projection, you take your global climate model, your GCM, and you initialize it in some way, and then you let it run. And that model will find its own equilibrium state, and it will produce its own weather patterns. It will produce its own storms, its own heat waves, and everything that we're familiar with the climate and weather. And using these projections, you can infer things about the changing types of events in a warming climate. So are we going to see an increase in extreme precipitation, or are we going to see an increase in drying in certain areas around the globe? But what you can never do with projections is match certain dates. So you can never say, okay, we're going to be able to see exactly what weather we're going to have in 10 years' time on this date. This is where the storyline simulations come in. And what the storylines do is they use a technique called nudging, and you can see it here on the figure on the right. So what I described before was if you move down, you look at without nudging, you can see the GCM, or the global climate model, producing its own types of weather. Whereas what we do with the storylines is we use this technique called nudging, where we use observational data, or in this case, error 5, so reanalysis data, to recreate observed weather from the past. So what this means is that we take the upper atmosphere and we use the wind data or dynamical variables to fit the upper atmosphere or constrain the upper atmosphere to recreate exact events. Now, we've run these simulations starting in 2017 up until 2024. So what that means is we have 7 or 8 years now of data where we can see how an extreme event would look in this type of simulation. But what's really novel about this type of technique is we can run these simulations under 3 different warming scenarios. So what you can see on the left, I've written them here. We've got our counterfactual scenario, which is where we run the simulation, but in a cooler climate. So this is on a climate based around the 1950s warming levels. We also run it in the actual climate, so recreating the event as it would have occurred or as we would have experienced it. And then we also recreate it in a future warming world of around +2 degrees. And I think this goes back to one of the responses on the Mentimeter just then, to understand how a certain event would look in a different type of climate. And that's exactly what these storyline simulations allow you to do. So we can take an extreme event that we witnessed, that we lived through, and we can analyze how it would look both in a cooler and in a warmer climate, and try to understand the contribution of anthropogenic climate change on that event. So to do these runs, we use the IFS FISA model that Jenny introduced at the beginning. And this is a global model that we're running at around 9-kilometer resolution with hourly temporal frequency. So, next slide, please. What you can see here is just an example of one of the events that we've looked at using these storyline simulations. So I'm sure most of you will remember this event occurred around Valencia in October last year. This was the Dana event, where we saw extreme precipitation occurring over one day on the 29th of October 2024. And you can see what we've written here. We had about a year's worth of rain fell in approximately 8 hours. So this was a really unprecedented type of meteorological event that resulted in over 200 fatalities and billions worth of damages. And due to the extreme impact and extreme scale of this event, we wanted to understand what was the role of climate change on the manifestation of this event. How much was it enhanced by? So if we look at the figure on the left, we can see the recreation of the Dana event in the first climate scenario, so in the control scenario. This is around a 1950s climate. And what we've written in the top of the panel there is the model simulates around 180 square kilometers receiving over 100 millimeters of accumulated rainfall. So this is over the accumulation over one day, and we see 180 square meters. Now, if we look at the event as it transpired in the actual climate, so the climate of the event as it occurred, this number nearly doubles, and we can see the model simulates 340 square kilometers over this threshold. Now, what's really interesting is if we again move forward and look at this event in a warmer world, so what would have happened if the same dynamic, same meteorology were to occur in a warmer future? We can see this number not quite doubles, but increases significantly again to 510 square kilometers over this limit of 100 millimeters. So this is a really interesting tool that we can use to dissect the role of climate change on different extreme events. It doesn't use the typical attribution framework to say what's the increase in probability of an extreme event occurring. Rather, we know that the event has occurred, and we want to see what are the changes in the thermodynamics of that event based on the current levels of anthropogenic warming that we've got, and on future levels of anthropogenic warming. So just to reiterate, we have these simulations at a global scale, so we can look at any extreme event at a global level between the years of 2017 to 2024. So this is a really powerful tool to look at extreme events and a different type of climate change attribution. So that's all from me. I think there might be a couple of questions in the next slide. Yeah, so we just wanted to know if anyone has seen this type of climate change attribution before. We're calling it climate change attribution, but it's also storylines is another way to just describe this kind of lived experience of an event where we can relate to. So I'll give everyone a minute to answer that. So that's really interesting. We can see that there's quite a few people here who haven't come across these types of simulations before. And that's really exciting because this is a growing field, and it's a a topic that's gaining in popularity as a way to communicate the impacts of climate change to events that we've all lived through, and we can understand how they might manifest in the future. I think we can move on to the next slide. Great. I think this is the last question from me. It's just an open-ended one. We just wanted to know how you might engage with these simulations, if you can see them being useful in any type of policy work, in any type of attribution work that you may be doing, or just if they'd be interesting from a general interest perspective. If there's some way that you can see your work engaging with these types of simulations. We've got a question here. Can the storylines be run using the sector relevant indicators? That's a really good question, and the answer is essentially yes. What we want to be able to do, it's still a work in progress, but we're building up the capacity to do this, is that all of the impact sector applications that we've just seen will have the ability to run not only with the projections from our climate models, but also with these storyline simulations. So that means we can see, for example, how extreme runoff may change for the Dana event that we just described. How could extreme runoff and flood risk be increased? Or if we looked at a heat wave, for example, how could the area at risk from wildfires be increased under a future warming scenario? So yes, we do plan on running all the impact sector applications via these simulations as well. And we've got a few different responses here. It'd be useful to use them in narratives to motivate risk reducing actions by linking abstract simulations with real world events. Yeah, that's a really, really good point. Could be possible to extend that to energy infrastructure risk, grid instability, and renewable energy. Yeah, so again, we can run these simulations through the energy use cases that we have to try and understand changes in capacity factor and how extreme wind events or extreme storm events may change in the future. Interesting, or I think even more simplified visualizations would be very useful towards stakeholders. So that's a really good point. If you have any ideas for the types of visualizations that you think would be useful, please write them in the chat, because a lot of what we want to do with these simulations is also engage with a broader audience and find ways of representing how these events will be changing and ways that people can engage with them. Great equivalent simulations, projections in urban settings. Yeah. Do you think it'd be useful to generate a catalogue of storyline trigger events for the impact community to analyze? That's a great question. Yes, I think this would be very useful. We've noticed different members of the climate DT community being interested in different events that have occurred over the last few years. So obviously I'm based here in Spain, so for us the Dana event is of really high importance, but generally people want to analyze extreme events that are relevant to where they live, to their country, and where they work and where they study, and where their life is. So I think it would be really interesting to start building up a catalogue of these events that the impact community could start looking at and trying to identify similarities and differences. That's definitely something we'd want to do, although it's not something we can promise at the moment. As you can imagine, there's a lot going on. Is the differences always that clear, or do you need experts to filter out the differences? Again, that's a really good question. I should add that at the moment, the results I showed, we're looking at one ensemble member. So that means we've run the model only once. And we're currently in the process of adding more ensemble members to get a better idea of the uncertainty quantification in the different results. So how much do the precipitation amounts vary between the different scenarios? But in some cases, if you're looking at you want to look at more the impact side, things like a heat wave, the differences can be quite clear, because you can look at simply what was the average temperature over the days of the event that you're interested in between the different scenarios. But if you want to dig more into the meteorology or into the synoptic patterns of certain events, sometimes you need experts to try and understand more about the differences or what was driving the differences. But sometimes it can be quite easy to pull out the differences between the different scenarios. And we've got create a storyline of individual extreme events. Yeah. And there's another one that I can't quite read. Where can I find more information about nudging? Is it kind of a spatially complex bias adjustment? So it's not quite a bias adjustment. There's actually been a paper, it's a preprint of a paper that analyzes in detail these simulations. I'm wondering if maybe Jenny or Francesca, if they could put or Susan could put the details of the paper in the chat. I don't know if that'd be something that would be possible. But essentially, it's not so much of a bias adjustment. We use data from reanalysis. So in this case, we're using error 5, and we're nudging the upper atmosphere winds every hour. So we do the nudging every hour, and that basically forces the meteorological variables to recreate the weather events over those days. And we'll post more information about how these types of simulations are done, how the nudging is actually done. And I think there was one more.
Yes, unfortunately, we are not able to scroll down in the presentation mode. But I'm not able to paste something in the Q&A right now, but we can add this information in the slides and make it available afterwards. That would be fine. We could just put the link in your section, and then users can find it.
That would be great. Thank you, Susan.
And we also have comments and one small question from Alicia Montoya. So a question is, which perils do you cover? And the comment is that it's a very valuable tool to be able to simulate different scenarios. So that's a thumbs up, and yeah, a small question.
The question was which variables?
Perils.
Can you define peril? As in, like, what type of extreme event?
Maybe Alicia, if you could. So yeah, natural catastrophe risks. Any risks that.
Okay. So any type of hazard. Perfect. So essentially, everything that happened between the years 2017 to 2024. So because we're recreating the global weather events between those times, any extreme event or non-extreme event, we could also look at a very, boring summer day if we wanted to, but that's not so interesting. Any extreme event that occurred within that time frame globally, we have the ability to look at. So this could be a storm event, it could be a heat wave, it could be looking at the monsoon in different areas, it could be looking at a cyclone that occurred. I should add that because of the nudging, the dynamics of any extreme event are quite constrained. So that means the winds are quite constrained, and we don't see so much differences in the different warming scenarios in these type of dynamical variables. And we mainly use them to understand the changes in the thermodynamics. So in the case of a storm event, like the one I showed you, the Dana event, in a warmer world, we're going to have more precipitable water in the atmosphere, more available moisture. And we can see how that increase in available moisture can translate into increases in precipitation. So to answer your question, any global event between the years that we've covered.
Okay, thank you. The question is answered very well. Thank you, Kat. I think we can move on, and I think there's one last question regarding your section.
Okay, great. What extreme events have occurred recently that you would like to better understand the role that climate change played? So this, yeah, really following on from the last question. Is there any extreme events that you lived through, or that you were aware of that you think would be interesting to analyze these scenarios? But the glorious storm. So that was a storm surge in the eastern Iberian Peninsula in southern France that occurred in 2020. This is one that we've been looking at. We of course had the Dana event that we just presented. There's also been a few. There was Storm Boris that occurred recently, but these are more European events. And we can also look at, there's been extreme floods in Australia. We could also look at these, for example. Emilia-Romagna floods, yeah. Cyclone Alfred affecting Queensland, yeah. There's been a lot going on in Australia. But Emilia-Romagna, yeah. So these are all events that can be examined. Floods in Dubai. And the LA fires. The LA fires is an interesting one because for that we would we'd be looking from the storylines. We could look at the meteorological conditions and then couple these with the wildfire use case that Suraj presented, and it'd be really interesting to see how the conditions for the LA fires would change. So this is really interesting. Thank you. It's just for us to kind of see what events are of interest to people. If we're looking more at flood events, more at heat waves, it seems like there's a lot of interest in flood events. This is definitely something that's gaining in frequency and damage. So this is really interesting to see. Australian fires, yeah. Fantastic.
Great. Okay, thank you, Kat. I think this was the last Mentimeter for the storylines. Before we come to the wrap up, actually, because we are running out of time, I wanted to highlight this one question from Anonymous, who asked, will you use the existing infrastructure of ECMWF under the Copernicus Climate Data Store to distribute further process the data? And I'm not sure if Jenny is still around because she had to drop off a bit earlier to catch a train, but she answered it really well, and I think we should also mention it again, that Destiny has its own infrastructure. It includes different components like the Destiny Data Lake, which is going to be implemented by EUMETSAT, the Destiny Service Platform that Jenny also mentioned at the beginning, which is the actual entry point for the users. And also, this is going to be implemented by ESA. And lastly, we have the digital twins who do the modeling. This is going to be implemented by ECMWF. So you can find the service platform link also in this presentation if you want to dwell in a little bit. And don't see any other questions for now. So this would be now the chance to ask another questions for all of the speakers, and now to actually wrap up because we are coming towards the end of the session. I would like to firstly thank all the speakers for their very interesting talks, and also to you, the audience, for listening and interacting with us. We have gained really many interesting insights from your side so far. Thank you for interacting with the Mentimeter. And now to conclude this session, we would like to have some final feedback from your side. If we go to the next slide. So now that you have heard a lot about the Climate DT project, because I know some of you never heard of it as you answered the Mentimeter at the beginning, How would you answer this question? What specific features of the climate DT or the data would be most valuable for your work? So you have heard about the general project, the use cases, and also this novel capability of storyline simulations, what if scenarios. Can you think of something that is that now changed your mind? What is now would be a valuable thing for your work? Would be really interesting to hear from you. Could be the storyline simulations, could be the actual new workflow, biodiversity corridors. Then we have another thing connected to the energy use case, energy demand and production indicators towards grid management. More feedback on the energy. Someone is very interested in the storyline approach. Very nice to hear. Easy and fast access, the energy use case, or trade-offs and high frequency, hourly or higher climate variables, use cases, economic versus nature trade-offs. Okay, that's already a nice set of answers. And looking at the time, I would say we can move on with the next question. To you. So do you have any suggestions on potential use cases or currently unmet needs that Climate DT could pursue in the future? So maybe you can think of another impact sector application that you think, okay, this could also use the streamed high resolution data, urban design. Again, we will leave this open for a couple of seconds so people can paste their answer. Business insights. Climate and health, landslides, avalanches, okay. Climate impact on finance. Great. Urban systems. Okay, thank you. Could we move on to the last slide, please? And this is my concluding slide now. And it asks you, how would you like to interact with the climate DT in the future? You have a bar that you can shift here. This would be very valuable for us. So how would you answer the question? I would like to learn more about the use cases in general. If you leave the bar to the left, you strongly disagree. If you move the bar to the right, you strongly agree. I would like to use the output climate data. How would you, I want to use the climate information system to support decision making. So we can also wait a couple of seconds here. We have already 9 people who voted. And there's a clear trend that people are really interested in this project. That's very nice to hear. Great. So this will be left open for a little while. And if we go to the next slide, please. This is a concluding slide. If you have any questions for our experts, you can see the contact here. You can also scan the QR codes for some further information for the Destiny website, where you can find information about news and events. There's also a newsletter that informs you about upcoming events. And of course, the Climate DT website, where you can find some more details about models, simulations, and how to actually access the data. And with that, if there are no final questions in the Q&A, I would like to give the word back to the organizers. And thank you all for listening and for your attention.